everyone. Once again, welcome to the course. And today we're going to look at mountains and climate change. That's such a weird combination, but okay, we're going to do it. So, there are different mountain ranges in the planet, but what you need to know is multiple mountain ranges make up a mountain belt. So, one of the biggest mountain ranges on our planet, the Himalayan mountain range or the Rocky mountain range. It's actually not a mountain range. The whole Rocky Mountains is actually a large belt of multiple ranges that extend all the way from Alaska through Canada into North America, down all the way into Mexico, where they kind of taper off. And then there's this thin little mountain range which kind of connects into the Andes down in South America. So there's this long belt of mountains that crosses the whole western part of the American continent, which is made out of multiple ranges. So you have the Sierra Nevada range and the Cascade Mountain range. There's multiple mountain ranges in the Rocky Mountains. And actually, if you ever take a flight out to California, or anywhere on the West Coast for that matter, you will cross these mountain ranges and you'll see, wow, hey, wow, those are the Rocky Mountains, but it keeps going. There's so many different ranges, and in between, there's like this flat open valley and space. And we'll talk about what kind of the mountains actually create different types of climates. So we'll talk about that. So anyway, so once again, facts: mountain ranges and belts are commonly located on the edges of the continent. They're part of the geosphere. And they cause air rise, and that's what leads to different climates, the mountain climates. So the mountains actually have a different climate of their own. So you could have, for example, the Himalayas are in the tropics. However, they have polar type climates because of their altitude. So we'll get to that. Mountain belts can be very long compared to their width. So if you look at the Rocky Mountain range, it's not that wide, but they're very long. So the older mountain range, the shorter the mountains, the younger the mountain range, the higher they're going to be. That makes sense. Because if they're older, they've had time to be eroded by the different elements. So whether it's snow, rain, air, whatever, it's going to be eroded away. Okay. If you look at the Appalachian Mountains, they're actually a very long and old mountain range. And at one point, they may have been taller than the Rocky Mountains and even than the Himalayas. But what happened was, over a long period of time, they've been eroded. And that's why it's not very tall anymore compared to the Rocky Mountains. The Rocky Mountains are also very old. They're so old that the cratons, or the very stable cores of the mountains, are what are being exposed, and that's how you have the what are those mountains in Wyoming called? Sorry, my brain just drew a blank. It happens. But it's called, here, the Tetons. The Grand Tetons in the Rocky Mountain range in Wyoming and Montana are actually these large cratons. And if you go to Yellowstone, you'll see a lot of the cratons too. These cratons are great also for mining, and that's why the Appalachian Mountains are in the condition that they are in right now. Moving on, Himalayan mountain range is actually very young, and that's why it is the tallest in the world. Okay. So one of the way these mountains are created are because of thrust movements of the crust and plate tectonics, and this causes folding and thrusting, And thus you have mountains. They just don't happen out of nowhere. So this also, mountains take a long period of time to build, and as they're built, they're also eroded down. However, we talked about cratons, which might be the solid inner layer of the magma plume or whatever that solidifies over a period of time, and those are also called batholiths. And as it's eroded away, they turn into batholiths. So there's different stages of mountain creation. There's the accumulation stage, when they're being uplifted, or when there's deposition also occurring. And then there's the orogenic stage, where they're uplifted at convergent plate boundaries. And lastly, there's the erosion stage. So there's different types of mountain range formation. There's block faulting. So you could have different, as the continents, the plates collide together or move apart, there are blocks of this earth that might move up and down. There's also areas where there could be a basin and a range. So there could be a range, and I talked about this earlier, when as you fly across the Rocky Mountains, east to west or west to east, you're going to see mountain range, and then there's going to be a large basin, then you're going to see a range, and then there's a basin. And actually, if you've ever been to Salt Lake City, Utah, it's actually in a basin area, and then you have a range on either side. So if you ever go to Salt Lake, Utah, that's a very interesting place. When I moved out to California back in June 2021, I drove across the country from Ohio to California. And as I drove, I actually got to stay in Salt Lake City. You drive through these mountains, and there's this flat area, then you drive through another set of mountains. And I thought that, driving through the Rockies is just going to be one long drive uphill and then one long drive downhill, but it's up and down flatness, up and down. And we come to a lot of desert type areas. So then we come to weather and climate. Weather describes what is happening in the atmosphere right now. It's a short period of time. So, when you ask your phone what the weather is going to be for the week, it'll give you what the weather is for the week, but that is not the climate. So that's why climate in general is the average weather pattern in a region over a long period of time. And climate specifically looks at the amount of rainfall and temperature in a region. So when you're talking about a region, it's not like one city or a town. It's a large region. So Northeast Ohio. So that includes Akron, Canton, Cleveland, Toledo, etc. So that's a large region. Then you might actually look at the whole Great Lakes region. That Great Lakes region has a very particular climate to the Great Lakes, which I kind of miss. So the Bay Area itself has its own climate, and it has microclimates, which has been very interesting. So, and you might actually find that the same in Cleveland itself. So if you're on the east side of Cleveland, so by the East Campus, it's one type of climate, or not, the weather is one type of weather. And you drive to the west side, to the West Campus in Parma, and there's a different type of weather happening over there. So the east side, we know it gets a lot of snow, and then you drive down to Parma, there's less snow. If you go to the west side, so Rocky River Campus, etc., there's usually no snow there. In fact, I'm like, most of the time when I would drive out there, they didn't know what snow was. And in the east side, we have 3 feet of snow, and people in the west side of Cleveland don't even know why we are complaining about snow because they don't have it. So those are microclimates, so that there's a little regional difference because of wind blowing a certain way. Climate change is how the climate is fluctuating. So these weather patterns, the average weather pattern in a region has fluctuated in the past, and it will continue to do so. However, the climate change a lot of people are worried about right now is how human impact is creating faster change in that fluctuation, which is supposed to be natural. So to understand this further, we have to understand the atmospheric composition, which you can study on your own. We talk about the oxygen level in the air, but it's actually a mixture of nitrogen and oxygen and a whole bunch of other things. One of the things which we're very concerned about is the carbon dioxide, and that is increasing, and that increases the heat the earth holds. And usually the earth has an energy budget, so the amount of heat the earth holds is of concern. And right now the earth is holding on to more and more heat. So that's the greenhouse effect, which everybody's talking about. The earth is has this thicker blanket, and if you know what it's like to have a very thick blanket in summertime and you're just sweating, it's not that nice. So think about that the earth is having this blanket and it's holding back more heat, and this creates a temperature rise in the atmosphere as a whole, not the air you're breathing currently, but the atmosphere way up, all around us. The average temperature of the whole Earth's atmosphere is increasing. And that is what is of concern to the global climate, not just the weather in your town right now. Okay, causes of climate change, there's natural causes such as volcanoes, and that's the biggest cause usually, but there is man-made causes, and right now the man-made causes is kind of like the tipping point. So for example, if you have a health problem, like say I have asthma and I'm doing everything that I can to avoid having asthma, and then I'm very, very allergic to cats. I used to be. I actually got treatment for that, but it's not 100%. And now I'm fine. But I go and I like cuddle a cat. That's going to increase my asthma response, and it's going to create my allergies to inflare, make it worse, even though I have 0 allergies right now. So that is pretty much what's happening. Like there's natural things, the natural condition, and then you're basically stirring the pot, or I'm having a hard time, but I hope you get the idea. If you don't get the idea, let me know. Okay, so there's multiple different types of greenhouse gases. So carbon dioxide is just one. There's methane and nitrous oxide and other particles and pollutants that go into creating this warming effect. In fact, the clouds end up becoming more heavier with these particles, and there's going to be more clouds because of these particles in the atmosphere. Oh, what else? Plate tectonics can sometimes release gases from inside the earth, but then it has to bubble through the ocean. But right now, the amount of carbon dioxide humans are releasing is actually more than what plate tectonics is doing, and thus we have a lot of issues with our ocean. If you look up, climate change in fish, you will see what's actually happening to the fish and the coral reefs, etc. But it's not just the coral reefs. Coral reefs was the canary in the gold mine. The other fish are being impacted right now too. So if you like eating fish, that's gonna be affected. How do we know about climate change over the millions of years? And it's studying paleoclimate, or paleoclimatology is studying ancient climate on Earth. And this is done by studying ice, the oxygen or air bubbles locked in ice. When you go study the ice cores in the Antarctic or the Arctic, the ancient ice has been, or even glaciers, you can actually look at what the oxygen or the air content was in these ice buckets, even in rocks. So that is how it's studied. So we know what the climate, the air was made out of, billions of years ago by studying what's in these rocks. And what else do we look at in this? So basically climate change, temperature is increasing, precipitation, so rainfall is increasing, and ice is melting. So glacier ice, polar ice caps, we literally do not have an Arctic anymore. So the North Pole where Santa lives, it doesn't exist. So who knows where he lives now. If you or your kids believe in Santa, he has no home. He's a nomad. But glacier ice melting, and that's why you see all those sad videos of the polar bears not having a place to hang out anymore. Very sad. Antarctic is still pretty solid, but that is because there is solid rock beneath that, so it's kind of sustaining the Antarctic or the South Pole. And South Pole is where the penguins are at, but that is slowly, there's a lot of glaciers and icebergs breaking off from the South Pole itself, or the Antarctica, let's call it that. That's the actual continent's name. And little penguins, all the various species of penguins actually depend on that. So those are being affected. There's multiple entities and intergovernmental entities studying climate change. There's the Climate Accord. They're all trying to make changes in the way they govern their countries and policies that are passed so that we can slowly start reducing our impact on climate. We all have a little bit of our part to play, like, turn off your lights and stuff. But also we can hold major corporations and our governments liable, because as individuals, we can only do so much, but then there are larger organizations that are using so much resources and polluting so much. So we need to start writing our letters and using our voices to impact these larger organizations. If you follow Greta Thunberg, she is a very young woman. I think she's, just graduated high school. She started making an impact from her young age. So don't be disheartened. You can make a change. You just have to have the determination that she did, and you can do it too. What else do I want to talk about? Okay, it's 28 minutes. What? Okay. So there's impact and consequences to climate change, and you can study this on your own. And we're always looking for solutions, sustainable solutions, not just, hey, ride the bus. There needs to be more than that. See you in the next class.